Ch20.3, page 29. Okay, look at this. 1 coulomb is a huge amount of charge. Actually, this one is correct because this bracket is very small. The force between two 1 coulomb charges 1 meter apart is about what? Put everything into the formula, you can find out the answer. The answer is this one. What is the calculation? Is this 1 over 4 pi epsilon naught? We know it. What is it? And then put 111 in it. The final answer is this. Okay, this one is very large value. If we can have 1 coulomb charges and 1 coulomb charges, but this one is huge amount. Very difficult found in the Earth. How about part B? If the force between two identical charges 1 meter apart and the force between it is 1 Newton, what is the amount of each charge? Okay, because these two are identical charges, it means that they have the same magnitude of the charge. Using the formula should be this. Okay, this formula should be coming from the original one. F is QQ over 4 pi epsilon naught R squared. But now we want to find out Q, so put everything here and then substitute it. Final answer is 10 to the power -5 coulomb. Okay, second question, true false. Coulomb's law is valid for positive point charges only. Is it correct? No. This one valid for any sign. You just only put the value into it. Even the answer is negative. No problem. Negative means that actually false. Positive means that repulsive force. Part B. Coulomb's law is valid for charged object of any shape, including spheres. The answer is wrong. This one true for spheres and point charge only. A sphere, okay, for the spheres, the force is applied for outside sphere, okay, not inside sphere. The sphere, all the charges will distribute on the surface. You can think that all the surface on the all the charges on the surface can concentrate at the center to represent the whole sphere. If like that, Coulomb's law can true for everything, including the sphere and point charge. Okay, number 3. Question number 3. Negatively charged, negatively charged attracted by two positive charges, of course, unlike charges. The upper charge is 4 times of the lower charge. For example, the lower part is positive Q, then the upper part will be positive 4Q. Attractive force on the negative charge by the upper charge is shown by the vector like that. Okay, center to center, draw a line. Next, carefully draw by ruler another vector to show the attractive force, okay, on the negative charge by the lower charge. Because this one is negative, this one is positive, they will attract each other, lie on the line of the center, okay. But you can see that this charge is greater than this one 4 times. Then in vector, the length of the vector represents the value, okay. Because this one is 4 times, then this, the force, the attractive force should be smaller than the original 4 times, like that. Okay, this one will be the answer, part A. How about part B? Sketch the resultant force. At the time, you will think that, this one is the mechanics. The same. You can use tip-to-tail method or parallelogram method to do it. Okay, use the parallelogram method. You can find out the resultant will be the diagonal of the parallelogram. Question number 4. The equation a guide to thinking. Okay, by substitution you can know everything. Into the equation we can predict how the other change. Page 25 bottom. Solve the following problem using this method. If both charges are double, what happened to the force? You should go back to the page 25 at the bottom one. Okay, You can apply the formula. What happened? Both charges are double. Now let me to write down the formula. Force should be the bracket QQ R squared. Okay? If the charge is double, 2 times, 2 times, 2 times 2 times, it means that 4 times. Then the force will be 4 times. How about this? If both charges are double, 2 times, 2 times, but the separation is double. Separation is double. But remember it, this one should be have the square. Then what happened? This one double, 2, double, 2, 2 times 2, 4. This one, distance double, square, also 4. 4 over 4 is 1. It means that no change, remains the same. How about part C? If one of the charge is double, the other one remain the same. It means that this one is double, this one no change means that 1, and the distance is triple. Triple is 3. Remember it, square. Okay, try to calculate what happened. This one 2 times, and this one keep the same. It means that 2. This one is triple, but remember that square. It means that 3 and should be 9. Then this force will be this one. Is it simple? In public examination, especially the MC, will use this method to test you. Okay, question number 5. Consider the following 3 arrangement. Rank them in descending order. Descending order means that find out the largest one, and then find out, and then next to next, finally will be the smaller one. Okay, based on the magnitude of it. Try to look at this. Here we have 3 different charges. You should try to think that how many forces in it. We can say that 1, 2, 3. The force between 1, 2, the force between 1, 3, and the force between 2, 3. And that's all. Okay? It means that among these 3 forces, we want to find out the value. This value should be depends on the charge and also the distance. For example, 1, 2. 1, 2, what happened? Should be QQ. QQ means that 1, 1. R is 1. It means that 1 square. Then 1, 1. It means that 1 and 2 should be 1. Proportional. And how about 1, 3? 1, 3, the charge should be 1. Remember it. I just need to focus on the value, the math only. This one is -1. It means that also 1. But the separation, the distance between is 2r. It means that this 2 square. Your answer should be 1 over 4. The last one, 2, 3. 2, 3. 2, 3 should be 1 and 1. And the separation is 1 square. The answer is 1. Which one should be the largest one? The largest one should be 1, 2, and 2, 3. The smallest one should be 1, 3. Then that's all. Okay. This one will be the calculation. Sorry. Here, try to find out the net inertial force. Okay, on the negative charge. It means that this. Okay, this one just need the comparison, and the question wants you to show the net inertial force. Okay, it means that focus on 3. It means that you should try to find out these 2 forces and then add them together. The same for this. Okay, 2, 3. 2, 3 should be the attractive force. Okay, attractive force, -1. For 1, 3, also attractive force. So we can add them together. 1 and 1 over 4 add them together should be 5 over 4. This value. Okay, for part A. How about for part B? the part B will be the center one. Okay, due to symmetry. What is the symmetry? You can draw a line of symmetry. You can find that reflection, 反射. Okay, in this case, positive and negative attractive force. Because this one is the axis of symmetry. If we have this force, we also have this force. Is it true? Of course. Positive and negative. And also the distance are the same. These two forces are equal in magnitude but opposite in direction. They will cancel each other, even though they are not action and motion pair, because acting on the same body. Okay, how about part C? This one is a 2D problem. Focus on the force acting on it, the same. Positive, negative, attractive force. Positive, negative, attractive force. Then you should combine them to find out this resultant will be your answer. You should ask that what is the value of it and this, and then use the Pythagorean theorem, then you can find out the answer. Substitution it. Okay, this, the bracket, Q square, all distance, and cosine 45 degree. What is the meaning? It means that we want to resolve this force into this component and this component. Okay, at the same time, this one will also resolve this component and this component, because in this resolving should be cosine 45, and this one are the same, so multiply them together times 2, then that's all.